welcome to this lecture on computer-aided power system analysis. In the last lecture, we have discussed about the sparsity of the Jacobian matrix, and then we have also introduced the basic concept of the Gaussian elimination method. So, now let us look at the details of the Gaussian elimination method. So, we will first take an example and then we will try to generalize this method. So, let us look at that Gaussian elimination, Gaussian elimination method. Now, as we have discussed in the last class, so let us take a small example of a 4 by 4 matrix. So, we had got this equation A11 x1 plus A12 x2 plus A13 x3 plus A14 x4 is equal to B1, A21 x1 plus A22 x2 plus A33 x3 plus A23 24 x4 is equal to B2, A31 x1 plus A32 x2 plus A33 x3 plus A34 x4 is equal to B3, and lastly A41 x1, A42 x2 B4. So, let us say that this is equation 1, 2, 3, 4. So, what we do in the first step, in this first step, step 1, so we say that these are the original equations, these are the original equations. So, in the first step what we do is, we divide this equation 1 by A11. So, the first we simply take it as a pivot element, we say that A11 is a pivot element. So, we say that A11 is a pivot element. So, we take this as a pivot element and then divide entire equation 1 by this pivot element. So, when I do this, we do get that x1 plus A12 by A11 x1 x2 plus A13 by A11 x3 plus A14 by A11 x4 is equal to B1 by A11. So, let us say that this is equation 5. Then what we do is, we now multiply equation 5 by A21, A31 and A41 one by one, and then subtract the resulting equations from equation 2, 3 and 4 respectively. So, let us say step 2, and step 2 will have part 1. Part 1 is that what we do, that we first multiply equation 5 by A21 and then subtract the resulting equation from equation 2. So, then therefore, by performing we write equation 2 minus equation 5 into A21, we get what we get. Equation 2 minus 5 into A21. So, what equation 2 is A21 minus again A21 x1 plus A22 minus, we multiply A1, we multiply everything by A21. So, it is A12 by A11 into A21. So, A12 by A11 into A21 x2 plus A32 minus, it would be A11, it would be A21 and it would be A13 x3, and lastly plus it should be it should be A24 minus A14 by A11 A21 into x4 is equal to B2 minus B1 by A11 to A21. So, this we can write down as this is 0, x1 is gone. So, let us say this is A22, let us say this is the first updated, this is the changed value A22 square bracket, within bracket 1 means that is the first modified value, is the first modified value x2 plus we say that it is A231 x3 plus we say that A241 x4 is equal to, let us say this is the first modified value. This is equation 6. Then in step 2 what we do? We do equation 3 minus equation 5 into A31. So, what do we get? We get A31 minus A31 x1. So, we are basically eliminating x1 from all these equations. Then we get A32 minus A12 by A11 into A31 x2 plus A33 minus A13 by A11 into A31 into x3 plus A34 minus A14 by A11 into A31 into x4 is equal to B3 minus B1 by A11 into A31. So, this is what we will get. So, we multiply everything by A31 and then subtract this from this. So, what we get? So, we get from here x1 is again gone. So, it is A32 the first updated value of x2 plus A33 first updated value of A33 x3 plus A34 that is the first updated value x4 is equal to B3, this is the first updated value. So, let us say this is equation 7. Then in the third, let us say in the third, what we do? We do equation 4 minus equation 5 into A41. So, what we get? Into A41. So, what we get? We get A41 minus A41 into x1 plus A42 minus A12 by A11 into A41 into x2 plus A43 minus A13 by A11 into A41 into x3 plus A44 minus A14 by A11 into A41 into X4 is equal to B4 minus B1 A11 into A41. So, A14, A41, A13, A11. So, this is it. So, this can be written as x1 is gone. So, A421 x2 plus A431 updated value, first updated value x3 plus A441 x4 is equal to B41. So, this is 8. So, then what are the equations we have? So, we have got these equations. So, now we have got equation 7. So, now what we have got? We have basically from the initial 4 equations, we have now basically eliminated x1. So, then we have got resultant 3 equations, and in these 3 equations there are only 3 unknowns x2, x3, x4, and we have got 6, 7 and 8. Now, what we will do is, so we have got 6, 7 and 8. Now, what we will do it? We will now take A21 as pivot. So, we will now take this as pivot. This one, this we have taken. Again, first thing here it was pivot, we call it pivot. Now, in the next phase, we will now take this one as pivot. So, when we take this one as pivot, so then what we do? We divide this entire equation by A2 to 1. So, when we do that, so in step 3, step 3, step 3 what we get? We divide equation 6 by A2 to 1. So, what we get? We get is x2 plus A231 by A221 into x2 sorry x3 plus A241 by A221 into x4 is equal to B21 by A221. So, now we call it, this is equation 9. In step 4, what we do is, we now multiply this equation 9 with A321 and then subtract the resultant equation from equation 7. So, then what we do is, we do in the first stage, we do 7 minus 9 into A321. So, we got 7 minus 9 into A321. So, what we get? So, we get is A331 minus it would be A231 by A22 into A321. So, it will be A231 by A221 into A321 this into x3 plus A341 minus A231 by A221 sorry it would be say 241 by A22 into A321 into x4, that would be B3 A31 minus B31 minus B21 by A221, B21 by A221 into A321. So, we get this. So, from here what we get, x2 is eliminated. So, from this we now get A33 second updated value x3 plus A34 second updated value x4 is equal to B3 second updated value. So, this let us say this is equation 10. Then in step 2, then in part 2 of this step, what we do is we do equation 8 minus 9 into A421. So, we do equation 8 minus equation 9 into A421. So, we get A421 minus A421, this is x2 plus A431 minus A231 by A221 into A421. This plus A441 minus A241 A221 into A421, that is equal to x4 is equal to B41 minus B21 by A221 into A421. Right. So, we get this. So, once we get this, so then this we can write down as x2 is gone. Once x2 is gone, so we can write down as that this is A432 x3 plus A442 x4 equal to B42, right. So, A43 x32. So, this is equation 11. So, I have got equation 11. So, now what we have got? We now from the 3 equations 6, 7 and 8, we have now eliminated x2, and by eliminating x2 we have now reduced it to 2 equations involving only x3 and x4. So, now what we will do is we will simply take this as pivot. So, we will simply take this as pivot, and then what we will do is, so then once we take this pivot, so we write in step this is step 5. So, in step 5, so what we do is we divide equation 10 by A332, divide equation 10 by A332. So, by this what we get? We get is x3 plus A342 by A332 into x4 is equal to B32 by A332. So, that is what I get. A342 by A332 A3 4 2 by A3 3, B3 2 by A3 3 2, right. So, this becomes equation 11, this is equation 12, and then in step 6 what we do is we do equation 11 minus equation 12 into A432. So, what we get? We get A432 minus A432 into x3 plus A442 minus A342 by A332 into A432, this is x4, that would be equal to B42 minus B32 into A332 into A432. So, from this equation x3 is gone. So, this we can say that this is A44 third updated value into x4 is equal to, let us say, B4 3. So, this is equation 13. So, now equation 13 only involves x4. This is known, this is known. So, then therefore, we now so now how do we solve? So, then the solution process. Now, we will start from backward. So, what is solution process? Solve x4 from equation 13. Then what is that? Once we get x4 from here, we will plug this x4 into equation 12 and then solve x3 from equation 12. Then what we do, substitute x4 into equation 12 and solve x3. Then what we do? Substitute x4 and x3 into equation, which equation we should now use? So, now x2, x3, x4 and x3 are known. So, now after that we can simply substitute x4 and x3 in equation 9 and then solve for x2 into equation 9 and solve x2, and then last one is that we are simply, so x2, x3, x4 into equation 5 and solve x1. So, that is how. So, you see we are being able to solve all this quantity x1, x2, x3, x4 just by simple algebraic manipulation, simple arithmetic, simple algebraic manipulation without involving any matrix inversion. So, this step can be very easily extended for any equation system. Now, let us just look at that how to implement it in terms of matrix operation. So, let us look at very quickly, it will take not much of a time. So, let us look at that Gaussian elimination. So, let us look at that Gaussian elimination through matrix So, now what we have got, for example, this one, if I say that this is, so this my matrix is A1, A2, A3, A4, A21, A22, A23. So, these are the equations. So, now for matrix operation purpose, what we do is we do denote them that this is R1, row R1, this is row 1, this is row 2, this is row 3, this is row 4. So, how do we translate this matrix operation? I mean how do we really translate all these operations by means of matrix operation? So, in the steps what we can do is that in steps one is that R1, this row is actually being R1 by A11, right. Then we do in 2, what we do, we replace R2 as is equal to R2 minus R1 into A21, R3 as R3 minus R1 into A31, and R4 as R4 minus R1 into A41. So, we get this new rows. In step 3, what we now do? So, now once we do this, all these terms would be 0, all these terms would be 0, that is basically this would be 0, this would be 0, this would be 0, and these would be 1 1 1 1 1 1 1 1 1. So, then we can simply say that this would be 0, this becomes 0, this becomes 0, this becomes 0. So, these all become 1 1 1. So, then after that what we do, that we do R2 is equal to R2 by A2 to 1. So, because you see this will become A2 to 1, and then in step 4 what we do? In step 4 we do that R3 is equal to R3 minus R2 into A3 to 1 and R4 is equal to R4 minus R2 into A4 to 1. So, this is what we will do. So, after we do this, so then what will happen? This will become 0, this will become 0, and this becomes A33 2. So, after that what we will do? We do in step 4. So, from here we are going here. So, this is step 4. So, in step 4 what we do? With step 4 we do that R3 is equal to R3 by A33 2, and then in step 5 we do R4 is equal to R4 minus R3 into A432. So, this also becomes A432. So, once we do this, this becomes 0, this becomes A443. So, then in the last step solve for first x4 followed by x3 followed by x2 followed by x1. So, this is how it will proceed by means of matrix operation. As you can see that these operations are very easy to follow. So, this can be very easily extended for a case where there are n equations or n unknowns. Now, here only one point needs to be noted, that in case in the process of elimination, if suppose any term becomes 0, for example, let us say A2 to 1 becomes 0. So, then in that case we really cannot do this. So, then in that case, in that step we really cannot take 82(1) as the pivot element, because if we try to divide this by this pivot element, so it will become infinity. So, then whenever any pivot element becomes 0, we do not take that as the pivot element, but we go to the next equation. For example, this one we take this and then we do take this as a pivot element and then proceed. So, this is basically the basic technique of the Gaussian elimination method. In the next lecture, we will be looking at one simple numerical example. Thank you.